Hi everyone, this is just a short video to give you some tips on how to solve problems for LCR circuits that are in resonance. Now there are a few things you could be asked to find out. One of them could be what is the resonant frequency. The other one is if the value of inductance or capacitance is not given, what is the inductance of the inductor or what is the capacitance of the inductor? Or you could be asked to find out what is the size of the current at resonance. So this is how we go about it. So what we need to keep in mind is an LCR circuit is one that has an inductor, capacitor and resistor in series, and at resonance this is your impedance phasor diagram. XC equals XL. So this is something we need to know. Okay, and also VL equals VC. Now, just looking at these two, XC equals XL, XC is 1 over 2 pi FC and XL is 2 pi FL. Now, if we get the frequency, so if you look at this and make F the subject of the formula, get this either side, so you get F times F is F squared, and over here you got 1 over 4 pi squared LC. So if you substitute, in order to get the resonant frequency, if you substitute the values of your inductance and capacitance in this formula, what you're going to get is the answer for F squared. And if you find the square root of that answer, you will get what is the resonant frequency. But if you want to so that's probably easier and you're less likely to go wrong, because your formula for F is 1 over, and if you square root this denominator, so square root of 4 is 2, square root of pi squared is pi, and then you get root L times C. So I would suggest use this and then find the square root of whatever answer you get. So that's how you find resonant frequency, and resonant frequency usually has FO. It simply means what's the frequency at resonance. Okay, so that's all good. Now, if you're given the resonant frequency and you have to find either inductance or capacitance, we use exactly the same formula, and it's always better to do it with the squared values, because otherwise you've got to do this and then square it. So you can either make L or C the subject of the formula, and you can get your value for that. So for example, if you have to find what is inductance, so making L the subject of the formula, you get 1 over 4 pi squared F squared C. So that's what you do in order to get inductance. Or if you have to find capacitance, you can't see that's over there. Just write it on the side. So if you have to find capacitance, C is equal to 1 over 4 pi squared F squared L. So that's how you find capacitance. Now, if you're asked to find circuit current, the way that you find circuit current is you go, I'll just rub these bits, some of this out. Okay. So at resonance, your Vs becomes equal to Vr, which is IR. And if you've got to find the circuit current, all that you need to know is your supply voltage is I times R. So I is equal to supply voltage over resistance, because that's the only thing that's impeding the circuit. So that's how you solve problems on resonant frequency.